Hey everybody, this is Larry. This is me going with Q3 of the weekly contest 394, minimum number of operations to satisfy conditions. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I actually submitted this twice afterwards. I'm going to use the old one. Yeah, just because I think this, because I want to go over why I got it wrong for a little bit. But yeah, so for this problem, let's go over it real quick. Right, you have these grid things, and the way that they say it is very awkward. But basically, all the columns has to have the same number, and adjacent cells have to have different numbers. Right, that's basically the idea. And there are a couple of ways you can think about this. Right. And I think example 2 is actually very good because during the contest I actually did miss this. Well, I missed this idea because I thought that you have to change it to like 102. I thought they have to be pairwise distinct, which is a little bit different, or they have to be unique, which is a little bit different, which is not the case if you look at this problem. So you convert it to 101, right? And the idea here that I did is very simple. The idea that I noticed is that N and M, or I'm going to use R and C because for me, it's just easier to remember rows and columns by R and C, not just N and M. I forget which is which. But the idea is still that there are C number of columns and C is less than 1,000. So I could do kind of lazy things about it is what I was going to say. But the idea here, so I'm going to go over my solution, and I know that there's an optimized solution that I'll go over a little bit. I don't know that I have it in code. We'll see what I do when I get to it, but I'll just go over my solution. And I got this kind of quickly in 7 minutes. Probably could have been faster, but I think I spent a minute debugging a typo, which you can see in the live portion, and that's what I'll show you. But yeah, but the idea here is that the thing that I use is dynamic programming, right? Dynamic programming, there are two-dimensional dynamic program. Index is just the column we are currently trying to fill. And then last is the value of the last column, right? So the idea here in a brute force kind of way is that notice that the entire column has to be the same number. So that means that if we the cost of changing that column to the same number is just the cost of changing the same number is just the cost of how many times the number appears, right? For example, if you have a column of like 100 rows and there are 5 ones, and you're trying to change the rest to ones, then you have to change the other 95, so that cost is 95, and so on. One thing I would say is, and maybe I won't, not yet. It's a little bit awkward, and you don't really need it. Maybe you do actually, but it's a little bit awkward for sure. But yeah, in a brute force kind of way, this is dynamic memorization. But yeah, and the base case is if we finish all the columns, we're done. Otherwise, we basically convert this to a number that doesn't exist. This is just one of my base case. So I just convert to -1 so that it cannot match anything that we have. But basically, just like you could say it's 999 or something like this, right? It doesn't, just like a random number that is not equal to any previous number. And of course, to do that, you have to add R, which is the number of rows that you have to fill. Otherwise, I have to do this pre-processing thing. And this pre-processed thing is just this thing, which is to say, we do a counter on each column. For each column, we just do a frequency table. So we just add 1 every time we see something. And then we calculate the cost by having R minus that number, right? So again, if you have like 100 row and a number appears 5 times, then it becomes 95 and so forth, right? Not so bad. So yeah, so that's pretty much the idea. So what is the idea, right? So index, what can it be? Index can be 0 to N, or 0 to C, sorry, which is up to 1,000 in this case. Last can be technically 0 to R because you can have R distinct characters. I'll go over it in a second if you are reading my mind, which is 1,000, right? And then, so number of inputs is going to be equal to, roughly speaking, O of R times C, right? But each input takes how much time? Well, it takes this thing which is O of all time, right? Because it can have up to all number of unique characters. So why is this fast enough? Because in this case, it is actually O of all times C, which is too slow. Well, it turns out that this is fast enough because of this constraint that I thought is still very weird that they kind of hit it this way. But it's fine. And technically speaking, there's another optimization that doesn't require this, but having this constraint allowed this solution to pass, because now last can only be 10 numbers, right? Because it goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it could actually go to, so this is no longer the 0 to R, this actually goes to 10, right? So 0 to, let's just say, what do I usually use for, let's say L for, or R for range. That's terrible. Okay, L for like the you know, the limits, right? So and this only goes up to 10. And in this case, the number of inputs is going to be L times C. And each input, remember, this now only has 10 unique numbers. So this is O of L. So now this is going to be O of L times C, which is 100 times 1,000, which is 100,000, and it's going to be fast enough, right? So this is the time now, right? No, space is L times C space. So that's basically the idea. The reason why I had a typo, I mean, I just had a typo. I don't know. I think I wrote something like this, and it was just wrong. But for some reason, I mean, not for some reason, Python just don't catch these things because it takes a shadow variable from the previous out of scope somehow, because everything is very magical, and didn't complain and somehow passed the exam. So I ate 5 minutes based on that. Very sad because it dropped my ranking by a lot. But yeah, so okay, so now we have an L times C time and L times C space solution. I just want to go over one real quick thing, is that another way of writing this, I actually pre-calculate everything, which is fine, but it's not actually necessary to be done this way. You can actually just do it once in a cached kind of way. So I think this code makes it a lot more readable in terms of, you know, and I don't think it'll be any slower, so it should be okay, right? So yeah, so cost is you go get cost, and then we just calculate this once for each column. Remember, this is also memorized, and that should give us the same thing. And yeah, it's a little bit slower because of the functional overhead, but it's so much cleaner to read and less margin for error, right? So okay, so this is the this is, as I say, the L times C solution. Can you do better? The answer is yes. Well, one is, and I'm not going to do this because I think I'm just lazy and tired. I'm not going to lie, but try to do this at home. Is that one is that, well, you can rewrite this as bottom-up dynamic programming, right? And it's not that easy as it is done, because last can, well, in this case, last, I guess technically from 0 to 9, but in a more generic case, last can be up to like R, right? And you know, it's not quite ideal. But the thing to notice is that after a column, let's say after a column, and let me know if this is too abstract, because I don't know. But it is a technique that maybe if this was a Q4, you might have to use, but for Q3, I suppose it is not necessary. But basically this idea of, okay, let's say you have a column, and then now you have all these inputs, right? Let's just use an example. Let's just say, you know, after the second column, and this is, you know, so index is equal to 2 or whatever, second, maybe 2. And then last can be a lot of things. So let's just say, you know, maybe for 0, it gives us the answer of, I don't know, 250. 1, it gives us 124. I don't know, I'm just banging on the keyboard. It doesn't really matter, right? Right? And dot, 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 right? And let's just say there's 1,000 of them because, I don't know, right? This is a harder problem, that's why. And then the thing with this version, right, is that the thing to notice is that, are we minimizing? Yeah, we're minimizing. Then when we're minimizing, what are we doing, right? Well, there are two things to realize if you write it bottom up. And I'm going at a very high level. I don't want to get into that much detail in the sense that you should try to really attempt this. I'm giving you all the pieces so that you can, and also I'm just lazy, so I apologize. I mean, if I wasn't so tired, I would have done better on this contest, to be frank. So do apology. It is what it is. But I do want to educate you on this because I think it's important. Is that if you do it bottoms up, and then you do the space optimization, right? Very common thing, very easy to do. And I have a video on. I mean, it's easy to do with practice, just to be clear. But it's easy to do once you practice it enough. And basically, and I have a video on that progression on converting it to space optimized. Definitely check that out. I think it's a good video for learning that. But what does that mean, right? That means that if you look at this recurrence, index, I mean, you could write this in reverse, but basically index, if you write it bottoms up, index only depends on index minus 1, right? So based on this observation, you can get rid of all the older index minus 2 things, right? Yeah. And that's basically space optimization. So what does that also mean in another world? What that means is that the last also only matters relative to the previous index, right? Let me write it down. That's only matters to the previous index. But what that also means is that because it's not path dependent, there is a pigeonhole principle for getting the minimum, right? Because basically, if you look at, say, the minimum 2 elements, in this case, it looks like it'll be these 2. Then now, let's say we're going to index 3 for what, I don't know, they're just building on whatever, right? And now we look at 2. The thing is that, okay, let's say we do an iteration on R, right? And there's another optimization that I'll point out later, but basically let's just keep the framework the same, keep all the thing the same. We're going to iterate everything, right? Well, the thing is that for every number, let's say we're on index, or with last is 0, then we basically minimize 0 plus all these other numbers, right? Not including 0, because that's where we have to k is not equal to last, because it cannot be equal to last. But the thing is, if we're putting 0 here, there are really no choices if you look at it like this, right? The only choice is you always take 2, because you know that everything else is going to be bigger other than 0, right? So then here you can choose 2, right? And then do the math, right? And then 1 is the same thing. 1 is, okay, look, we have to skip this one, but everything else, you're not going to choose these, you're going to choose the 2. So then now we choose 2. And then now 2 is, of course, a little bit interesting. You cannot choose this number, but then now you choose all the other numbers. And again, you don't have to choose all the other numbers. You can only just choose 1 because you know that it's going to be inferior, right? Choose 1. And then 3, same thing, you choose 2, right? So ... Right? So here, notice that we only need to retain 2 numbers, right? And that's pretty much, and that's the idea. But does that save you time? Well, not yet, right? Because, I mean, you can rewrite this to save you space, because you only need to, you can now delete this, and so it saves you even more space, right? Because now you only need to care about 2 things, which is the minimizing on all these other things and the number 2, right? Well, now let's take a look at this, but reverse it, right? What happens? What happens is that now we have 2 things we can do. We can choose 1, or we can choose 2. If we choose 1, that means that previous is 2. Here, choose 2. Wait. Oh yeah. Previous is. Oh no, I think I wrote this. Okay. So if, sorry, let me rewrite this. It's a little bit confusing because we reversed it. So choose previous one, right? Because this is choosing from the previous row. Choose previous two. I think that's why I want to rewrite this. Right? So choose previous one. What happens? That means that the current choice is 2, right? There's only one thing. Everything else we choose 2. And then here, current choice is everything else. But what does this everything else means, right? Well, for this column, we already calculated. You have to do the cost once. But after that cost once, it doesn't matter anymore, right? Because here, there's no current choice. It's just that if the current choice is not 2, then the current choice is everything not 2. And because the function is that you just add that cost anyway, then we want to minimize the cost, which we can also pre-calculate, right? So basically, that's it. And then now, if you do it this way and you have to write data structure, right? Then now, I don't have the code up, so it's not super clear, to be honest. So to be clear, this is still going to be O of R times C is linear because you have to, at the very least, read everything by every cell. But now, as you iterate through it, and keeping in mind that you don't have to sort anything, right? You only need to keep track of min 2 elements every time. So that means that you can go through the array twice. And that means that in here, okay, like I said, it's rewritten, so it's a little bit funky to look at the code this way. But only the index matter. Last can only be 2 things, right? You only care about the min and the second min. And because the input now only has 2 things, sure, you still need to do a row because you have to go through everything once. So this is going to be O of R times C times 2 time and O of R times C space, right? Well, and of course, R can be further reduced by the number of unique variables or numbers in a row or in a column, sorry. But yeah, so the conclusion here is we can reduce this to O of R times C time and O of R times C space if you're careful. So yeah, so that's pretty much, I just want to bring up the stretch goal if you want to kind of upsolve this a little bit more. And if this was the Q4, you probably would have to make this optimization. And I don't think that's that hard of an optimization. To be honest, some part of me slowing down was because I was like, do I need to do this? Like, I knew that the other way would be roughly fast enough, but with Leetcode is sometimes not always clear and sure for me anyway in Python. So yeah. That's all I have for this one. Let me know what you think. Thanks for watching, and you could watch me solve it live during the contest with this stupid typo. Next. 300. Alright, let's go. Alright, let's go. 2-digit grid of any cell to any non-negative number. You need to equal to the cell below it, and so basically all the columns are the same, all the rows, all the columns are the same, all the rows are different. So now you convert it to, it doesn't have to be distinct, just different, huh? Oh. Does it have to be from 1 to 9? I guess it. No, but it doesn't matter. You can brute force this. Well, what is the cleanest way to brute force this? Oh, people got it already. That's one. I mean, you could dynamic programming too, I guess. Is that really the best way? Well, it can only be 9. Okay, yeah, let's do it that way. We want to column. Okay, yeah. Yes, that's it, actually. We need to pre-process. At least the way that I'm doing it. Okay, fine. So, alright, you got this, Larry. Come on. For each column, we want to say F is okay, and then now we want to say oh, okay, yeah. Oh, this has to be different. Okay, fine. Is that right? Okay. And now for each column, and then maybe last. Why am I so slow on this one? Okay. The best is equal to go index +1, last is 999, it doesn't really matter. Plus R, because we changed the entire thing. Okay. And now best is equal to min, best go index +1, f of k. No, k plus f of k. That's if k is not equal to last. That's pretty much it. I is No, whoops. Zero 3 2. Oh, okay. All right, let's hope it's fast enough. Oh snap! Did I misunderstand the problem? Output 1 expected 2. What is this? 0 8 8 2. What do I change it to? Oh, this is silly, Larry. What a typo. What a typo. What a typo. Oh, man. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, explanation. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.